It is time for video lesson number 19, and today's lesson is on the properties of mathematics. Today, of course, you will need the TOC you were given in class, a pen or a pencil to take notes, a highlighter, marker, or colored pencil to highlight key words, and this is part of the calculator section, although it's mostly about vocabulary, so you're not going to need one. The important thing to remember about properties, you've had most of these in elementary school, but you have to really memorize these properties. There's no way around that. You have to know what they are and be able to apply them. There aren't going to be direct questions on your SOL this year, but you are going to have to be able to answer questions about them. They're going to say what property is being used in this equation, and you'll have to answer that kind of question. But you have to have them memorized in order to answer that kind of question. Let's start on our first property. This is the commutative property, and it works with addition and multiplication. And basically, it says that you can change the order of the numbers in an addition problem or a multiplication problem without changing the answer or the sum or the product. And the way this works, it's kind of like going from home to school. That's commuting. Commuting is going from one place to another. At the beginning of the day, you go from home to school. At the end of the day, you go from school to home. I go the same distance. My answer, my distance is the same both ways, but my distance or my direction that I traveled is different, where I started, but my distance is still the same. So look at your examples. I had on the left side 3 plus 2 plus 1. 3 plus 2 is 5, plus 1 is 6. If I rearrange the order of the numbers, so now I have 1 plus 2 plus 3, 1 plus 2 is 3, 3 plus 3 is still 6. So I can take those numbers and I can move them around in an addition problem, and it's not going to change the answer. So that's basically, it helps my brain be able to move around addition problems so that I can add numbers that make more sense, like 6 and 4 or 3 and 2 or whatever makes more sense for those number families to make me be able to do mental math easier. The second example, we have 5 times 8 times 7. I can rearrange this so I can do 8 times 7 times 5. If I know 8 times 7 is 56, and I can multiply 56 times 5. That kind of thing. It's still going to get the same answer. If I look at the next example, this is a little bit different because it has letters. Those variables are in there. And this is the kind they always throw at you because you think they're going to move those parentheses, but they're not. The 5 plus the A is going to stay in parentheses. All they're going to do is they're going to move the parentheses so that it comes second and the B comes first. B plus the quantity 5 plus A, still going to give you the same answer. Now, with those letters being there, you can't really do anything, but just know that you can switch them around if you need to. An easy way to remember this is because I'm changing the order to CO. Look at the first two letters in the commutative property is CO, change order. That's just a quick way to remember that. Go ahead and circle that with some sort of colored pen or marker so that you remember that little trick, change order. All right, let's talk about that second property. It's called the associative property. It also works for both addition and multiplication. And basically, it is talking about how we group numbers or regrouping numbers. So remember with grouping, that is using parentheses. So regrouping means we can change where those parentheses are. And if we change who was in the parentheses, changing the numbers that are in the parentheses won't change the answer to our problem. So if I continue reading what it says, changing who is in my group or my associates isn't going to change my answer. So, fun way to remember it. If you look at the pictures at the bottom, it's kind of like Amber, Cindy, and Barbie are all best friends. And one weekend, Amber and Cindy decide they're going to go to the mall, and Barbie has to stay home and babysit her little brother. But that doesn't change the fact they're all still best friends. Just Barbie can't go that time. And then another weekend, Amber has to go out of town to her grandmother's birthday party, and Cindy and Barbie get to hang out at the mall. So they're all still best friends, but each weekend it's different. Doesn't change the fact that they're all best friends. So let's look at the first example. We have 3 plus 2 plus 1. 3 plus 2, I have to do that first because that is in parentheses. That's 5. Plus 1 gives me 6. But if I rearrange that so that 2 plus 1 is in parentheses, that's 3, and then I can add that to the other 3, I still get 6. It doesn't matter that I changed who's in parentheses. I still get 6 on both sides. So they're saying that I can change who's in those parentheses as long as it's addition and not change the value of the numbers or the final answer. Same thing with the second example, 5 times 8 times 7. Maybe I'm not good at 8 times 7 and I want to do 5 times 8. I'm going to rearrange those parentheses so it's 5 times 8 first because that's 40, and then I can multiply 40 times 7 because I know that 4 times 7 is 28, and all I got to do is add a 0, and it's 280. I can do that. And then the last example is a little bit tougher because it's all letters, so I can't really solve it. So I would just rewrite it as A plus B in parentheses plus C at the end. Again, that's changing who's inside the parentheses. So you're changing, just moving your parentheses, but you're not changing the order of the numbers or letters. All right, there's two properties that are very similar. This one is addition only, so put a big plus sign here. This is additive identity property. It has to do with keeping the number the same. So it is adding 0 to any number keeps the value of the number the same. And the little saying you can remember is I am who I am, and that's my ID or my identity. So if you think about if I have 3 and I add 0, I still have a 3. If you look at the second example, this one's a little bit more intense because I have 25 times the quantity 0 plus 4. Well, if I have 0 plus 4, 0 plus 4 is just going to give me 4. And then I can multiply that times 25 and get 100. So it's just knowing that any time I add 0 to a number, I'm not changing the value of that number at all. So that's the identity property for addition. The identity property for multiplication is very similar. Same kind of concept. It's not changing the value, but you can't multiply by 0 and not change the value. The only number you can multiply and not change the value is if you multiply by 1. So you have to know that difference. Adding by 0, multiplying by 1. If I multiply by 1, I don't change the identity of the number. It keeps the identity of that number the same. So 22 times 1 is still 22. Look at the second example. It's that more complicated problem. 55 plus 5 times 1. Well, 5 times 1 is still just 5. So then I get 55 plus 5 equals 60. So again, multiplicative identity, I'm just multiplying by 1. And that multiplying by 1 does not change the value of the number. Now, those were the identity properties. These are the inverse properties. And I want you, next to the word inverse, I want you to write really big, undo. It's over in the definition, but inverse means to undo. So, how do I undo addition? Well, it's like subtraction, but we just went through our integer unit, so we learned that there really is no such thing as subtraction. It's just adding the opposite or adding the inverse. So adding the opposite is like adding the negative version or adding the positive version. So if it's negative, you're going to add the positive. If it's positive, you're going to add the negative. So you need to know it's adding the opposite or the inverse. We'll undo that number. So look at the examples. If I have a positive 6 and I add a negative 6, guess what I end up with? 0, nothing. If I have $6 and I spend $6, I get nothing left. If I owe $9, how do I get 0? I have to pay that $9 back. So I have to get that $9 back. So the additive inverse is all about adding the opposite to get 0. Multiplicative inverse is a little bit different. It is also undoing, but you're not getting 0. You want to get 1, not 0. So I want you to, that is included in the middle in that definition. You'll say this will equal 1, not 0. But if you think about when we did fractions and we multiplied and divided fractions, we used something called the reciprocal, and we talked about that we multiplied by the flip. That is the multiplicative inverse. So to undo multiplication, you actually divide. Well, to divide, you multiply by the flip. So when we undo multiplication, we multiply by the reciprocal. So that's where this comes from. So you're going to actually take what you have and then flip it upside down and just multiply by that flip. So, and then instead of getting 0 at the end, you end up getting 1. Because if you think about the identity property, with addition, you want to get 0. Because adding 0 doesn't change the number. But if you think about the identity of multiplication, you don't get 0, you get 1. And multiplying by 1 doesn't change the number. So it's kind of multiplicative inverse works with multiplicative identity. You want to get to that value that won't change the number. In this case, it's 1. So how do I get to 1? I take, if you look at our first example, I have a 3. Well, you'll say, there's nothing underneath the 3. You have to remember there's a hidden number 1 there. So take the 3, flip it upside down, I get a 1/3. When I multiply those together, I get 3/3, which is the same thing as 1. What about 3/7? What's the inverse of 3/7? 7/3. We all did this when we divided fractions, so this is nothing new. It's just like dividing fractions. We're just taking it and multiplying it together to get 1 at the end. That's the multiplicative inverse. All right, multiplicative property of 0. 0 is the hero. It says that multiplying any number times 0 will result in a product of 0. Just means that anytime you multiply by 0, you get 0. 15 times 0 is 0. 29 times 0 is 0. 1 billion times 0 is 0. All right, last property we're going to do is the distributive property. And this property is not on this year's SOL. You won't have to be tested on this. It won't be on your quizzes. It won't be on your test. It won't be on your SOL. It's just a review because you're going to be moving into this in 7th grade and in 8th grade, and we just wanted to keep it fresh in your head. So write a big star next to this to say not on your SOL, not on your test, because you don't want to know this. But just to keep it fresh in your head. The distributive property is that property that says we're going to share by multiplication the number on the outside of the parentheses with all the numbers inside the parentheses. I like to think of it as the angry bird kind of gets shot and he knocks all the pigs on the inside. Oh, out, whatever. So if you look at our first example, 2 is on the outside and he's going to get multiplied by everything inside. So he gets multiplied by the A and he gets multiplied by the B. So it becomes 2A plus 2B. Look at your second example. You have 5 times A plus 5 times 2, and 5 times 2 we can simplify to 10. And that's the last property we have to know. It is time to show what you know. Log in and take your homework quiz.